So we continue our exam in assembly section. So this is our part, assembly model 1. So we need to have 4 different bays. This is the base, crankshaft, piston rod, and piston head. We create a proper mates as shown, so we have all mates, and mate the front planes of the piston head, and so on. So we have instructions that we should create the part as shown in this picture, and then we'll change in the next question. Okay, so this is for solid model, this is for assembly model. Let's try to create. We have part. First we need to add to our assembly environment base model. Let's go to try to add our assembly. So open the assembly environment. Let's go to insert components. So from here we should go back and we should go to exam and assembly 1 and the base part. Let's try to add and fix the base part first of all, and let's go one more time. Try to get all those crankshaft, engine piston, piston head, and connector piston rod. Let's try to open all those one by one. So crankshaft, this is a final part, so we don't need assembly. Let's go to add one more time, piston head and piston rod. This one and also this one. I think this is all what we need in order to complete this assembly. Okay, first let's try to rotate our part. How you can rotate? Just hold the right click on the part, up and down, left or right, you can rotate your part. Left click, hold the left click, you can move the part. Right is for rotate, left is to move the part. Let's select this one and also this one. Let's make them while you select these two features together, hold the control key. This is like exactly the same way what we do in sketching environment when we give the relationship, right? Let's try to give the concentric relationship, or you can go mate. You can give mate as well. Okay, let's see the part. So we need to have this face and also this face. Let's connect them together. So when you should be able to rotate this part. Okay. Next we have a couple of connecting rods. This one and this concentric. Okay. So it should be good when we use advanced mate types, but in this case we don't need. This is just we need to select this face and also this face. Let's connect them together. So in order to copy this part, you just need to hold the control key, select, drag and drop one and one more time. Let's select this face and also this face, concentric, coincident, and this one and also this one. Make it concentric. And again this face and also this face, coincident, and this face and also this cylinder face, concentric. Done. So the next we need to add these two. Select this face and this face, and also this face and this face. Okay. Drag and drop one more time and drag and drop one more time. Select this and this, concentric. Okay, move back, select this face and this face, make them coincident. Select this and this one more time. Okay, so when I rotate, they should rotate accordingly. Okay, so what is the next? Create the appropriate mates as shown. Mate the front planes of the piston the coincident to the front plane of the base. So we have front plane of the base, and also we should have a front plane of these each piston. So we should have made those, and we have parallel relationship to this face to this face. Let's give them. Let's select this and this, and also this. Make all them parallel with Smith's mate. First just only this, then we'll do rest. Okay, this and this, should be the same way. Make them parallel. I didn't make them parallel relationship, I made coincident relationship, what I believe. Yeah, edit feature. This should have a parallel relationship. Okay. No, this should be parallel to this. And done. Click OK. Now let's try to see the front plane. I mean this base sketch. Let's try to see the front plane, hide and show the front plane. If you don't see the planes, you should activate it. Okay, so this and this should be coincident on the other way. Oh no, let's try it one more time. Let's try to see this first. This one and also this one should be coincident in this way, and this plane and this plane should be coincident, not symmetric. Okay. Okay. So now you can select and hide the plane, or you can hide all like that. Okay, we did this. So what is next? We have all these relationship. As you see, you should check all these. So as you see, we have coincident over here and concentric. That all we did all those. So we have the create angle made as shown in the figure. 45-degree angle. We should have this 45-degree angle over here. Then we need to check the central mass of the assembly with respect to the new coordinate system. We should build a new coordinate system as well, as you see over here. Let's try to give this coordinate system y, z and x. So in order to build a new coordinate system, we need to go to reference geometry and coordinate system. Let's click this point. As you see, x, y and z. Z should be in this way, right? So we should go to z axis and select this and reverse direction. Now for x, reverse direction. Let's try to give x-axis. For this one, this should be x-axis, other way, and y-axis, and this way. Okay, so I believe this is correct now. Z, this one, z, x-axis, and this is y-axis. So this is correct coordinate system that we built. So we have new coordinate system. If it is not shown again, you need to go here and check just to show your coordinate system. Oh, my SolidWorks crashed. Just a second. Let me fix it. Okay, I fixed that. So my SolidWorks just crashed. Okay, so the next question is to give an angle between. Let's see the question. Between this line, or you can select these edge as well. I mean between this edge and also one of these edges. So we have 45-degree angle relationship. Or we have this reference sketches, and also this reference sketch you can just create this right click and open a new sketch. You can create this line and you can give angle relationship between these two as I given over here like that. So the made selection, select this line and also this new sketch that I've created and give an angle between them. Let's try to give try to suppress this angle right now, and let's try to select this edge, and also let's try to select this edge and also this edge, and let's try to give angle. As you see, angle is 45. So we have already given this. You can, I mean, you don't need to create these all the time. If you have an option like this, you can give the same angle. But if you make sure that this is straight, I mean, this is straight as its center line. then you can give this, you can use this option easily without creating additional lines, but all works fine. So I already gave them, that's why I just suppressed. So next is to check what is the central mass with respect to new coordinate system. So we need to go just mass properties, evaluate in this case. Let's go to mass properties. This is the report coordinate values relative to, not default. We need to select coordinate system 1. So in a coordinate system 1, the central mass is minus negative 25.85, 25.85, and 113.54, and Z 173.53. So this is correct. So we have completed our first question regarding assembly modeling. Now it's time to change that angle to 135 and report your let's change this to 135. Let's click OK. Let's click OK one more time and see the part. It's exactly the same as it's shown. 135, 135. You can still go to evaluate measure. You can always just check the degrees 45, and on other way it's 135 angle. So it measures from here to here, but we need to know from this line to this line. This is 135, this is 45. So this is correct now. So we can go to mass properties. We can evaluate our central mass. We can select. We can define our central mass. So we need to write over here, or we can check minus 25.85. Let's go here. 25.85, 104.75. So this is correct. This is correct. So we need to save as this question. So now let's try to move our second assembly model. So we have this mount, creating assembly with the following parts. We have mount, cylinder, piston, and A arm. And also we need to create this A dimension for this piston, and we need to update the parameters and report the answer. Okay, let's try to build this. Let's close this, try to save as always, and I'm opening a new assembly. Okay, so we need to go back and select assembly 2. So what we need to add our mount first. Mount. Let's click open. So this will be our mount fixed, and we have our cylinder again. Let's try to add cylinder. Insert component. We have our cylinder. Let's try to add. So cylinder, we have a connection, coincident relationship, and also concentric relationship. Let's select this and this, concentric, and also this face and this face, coincident. Okay, let's try to add this, our piston and arm as well. Insert component, our piston and arm. Let's open it. Arm, let's click OK, and piston. Okay, what relationship we have for this part? Again, concentric and coincident. First, let's go with coincident. You can use smart mate option as well. Like hold the Alt key, select this face, move. As you see, the now its mating option is active. You just select this. It automatically give the concentric relationship. So rotate it back. So now we need to give the same to this side. Hold the Alt key, select this. Let's give to this side. Let's click OK, and select this and give to this side. This needs practice a little bit. Okay. Okay, yeah, it takes time. Okay, what is next? We need to add concentric relationship, this one and this one. Great. Okay, what is the question? We have added proper mates as shown. So we have a dimension over here, and we need to measure the x dimension from this point to the bottom point. And we have this cutting line shows the section view, and we should give this distance. So in order to do that, let's try to select this, make this tangent. So we have a tangent now, right? In order to see this, so we should have a selection for this part and also this part. I don't know if we can use section view for this case. No, we need to adjust it. Anyway, let's try to select this face and also this face, not this face. You can use edge as well. Let's try to give let's try to go mate options. So now it doesn't show the mate options as it is shown over here. Very interesting. No, of course no. So we should be able to select not face these two edges. Let's try to select these two edges. Go back. Oh, the easiest way. Let's try to move it back. Right click, go to the mate, and we have a lot of options. Just select other. We have a faces as shown, the face, this face, rotate and right click, select other, and which face we have, inside face. Yes, we have this face as well. Now we have distance options. What is the A dimension in this case? A is 20. So type 20. Let's click OK. Oh, we have selected inside face actually. Select this and right click, select other. We need to select face, and we need to give distance 20 and enter. Let's click OK. Let's click OK one more time. Select and uncheck transparency. So it's time to measure this x distance. Let's look at from right side. Measure tool, evaluate and measure from this point to this point. We should have y distance. The y distance 48.36. Let's try to see 48.36. So this is correct now. Now it's time to update the assembly and try to see the changes. What is the value of the length x between the bottom edge of the A arm and the bottom face of the mount? So we need to add 5 now in this case. Let's go and check. You just go directly to the distance mate, edit feature, and instead of 20, let's make it 5. Let's click OK. OK one more time. And evaluate, measure from this point and this vertex point. So we have 20.15. Let's go here, 20.15, and this is correct too. So as you can see, we have completed our assembly section. So in the next section we will try to complete our advanced part modeling as a last question in CSWA Associate exam. See you in the next video.